I am Garima Tripathi, and under the subject Pharmacognosy and Phytochemistry 2B P504T, lecture 35, we shall be discussing chromatographic techniques in phytochemistry, where adsorption, partition, ion exchange, molecular exclusion, affinity and Prepper chromatography. So, the term chromatography itself is meant for the separation of the substances or purification. So, it works under the mechanism of like likes the like. So, herein whatever is same will dissolve the similar substance and will separate out. So, the technique in chromatography is a lab technique for complete separation of mixtures which are dissolved in either fluid, gases or any other form, and then carried through the system completely. So, the technique creates a basis for analysis and separation of wide range of physical methods used in complex mixture. The term chroma says chroma means color and graphy is recording on a print media. So, that is how we bifurcate the term chromatography. This term was derived from the very first experiment which was conducted by a Russian scientist to separate the plant coloring pigments of the leaf using N-hexane. So, here there are two phases, number 1 the stationary phase and number 2 the mobile phase. So, the mobile phase, whatever mixture is mixed into the stationary phase, the mobile phase will come and it will solvate, and whatever is likable to this mobile phase would be carried along with it and will separate out. So, whatever anything which is having more likability to the stationary phase would be separated at the end, and anything which is having the likability for the mobile phase would be separated at the fastest time schedule. Okay. Next, each component has a characteristic time of passage through the system, and this particular passage time is termed as retention time. Now, chromatographic technique is achieved when the retention time of the analyte differs from that of the other components in the sample. Next, the difference in the rate of travel results in the separation of the individual component. Smaller the affinity of the molecule has for the stationary phase, shorter time spent in the column. This could also be substituted for the plates in case of planar TLC and paper chromatography. A chromatogram takes a chemical mixture carried by liquid or gas and separates it into its component parts as a result of differential distribution of the solutes as they flow around or over the stationary, liquid or the solid phase. If the right adsorbent material, mobile fluid and the operating conditions are employed, any soluble or volatile component can be separated using chromatography. Even structurally similar components can be separated with chromatography. The principle of chromatography differs according to the stationary phase and the mobile phase. Now, throwing light on these typical terms, that is adsorbent materials. So, the adsorbent material here can be any material like cellulose, then we have silica gel, silica, gel, we have Keshalgarh, aluminum hydroxide, and there are n numbers of list of the adsorbent material available for chromatography, which is applicable for any of these, either planar or the non-planar chromatography. Then we have this stationary phase and the mobile phase, defining this characteristics. Since the stationary phase is the fixed phase, and herein if this stationary phase is polar in nature and the mobile phase is non-polar in nature, then we classify this kind of chromatography as normal phase chromatography. Now, since we say that if the substance depending upon the type of substance to separate, we may change the phase of the chromatography or and we term it as reverse phased chromatography. So, what is done is the polar adsorbent materials or the substances are selenized or metallized and then turned to non-polar, and the mobile phase instead of polar non-polar, polar mobile phase is used. So, here you can use this stationary phase polar, mobile phase non-polar in normal phase chromatography. Next is the term retention factor. Let us see here, retention is nothing but a measure of speed at which the compound moves in a chromatographic system. In continuous development systems like HPLC or GC, where the compounds are eluted with the eluent, the retention is usually measured as the retention time RT, and this is the time between the injection and detection of the substance. That is, injection means addition or sample application, and detection when it is identified that it is separated out. Now, there are two terms, eluted and eluent. Elute means removal. Elute means removal of the substance. That means removal of the analyte, and eluent is the solvent, what you say, solvent or the substance which carries this particular substance away. So, that is called as eluent, the solvent which will remove it or which will carry it, eluent. And what is obtained is termed as eluate. Okay. Now, every time a chromatography, in case of column chromatography, in a specific time schedule, we take various fractions where there could be A plus B, then we have here B plus C, after some particular time C plus D, or sometimes plain D. Every time a different fraction is eluted out, each fraction is detected. This we shall discuss in the coming topics of column chromatography, just to make you understand that at the point of injection and when it is detected will be termed as the retention time. For this fraction A, B, the retention time would be T1, while for B, C the retention time will be different, that is T2, since it would be detected at this time frame, and similarly for D, maybe it will be T4. Okay, next term is the retention factor RF. In an uninterrupted developmental systems like TLC, TC, that is paper chromatography, the retention system is measured as retention factor RF, and the run length of the compound is divided by the run length of the eluent front. So, RF is defined as the distance travelled by the solute divided by the distance travelled by the solvent. So, let us give a little light on this. What do you mean by uninterrupted developmental system? What do we mean? See, in case of column chromatography, it is we have the control to take the eluent at our discretion of the time frame. But once a planar chromatography, or planar chromatographic system has already been started, there is no control. Once we have kept the paper or a TLC plate for development in a solvent system, it will be uninterrupted. The components will separate at its own discretion, and then we will finally detect when the given length is already achieved. So, that is called as, so here in such cases we calculate the retardation or the retention factor. So, it is needful to mention here that there are on the basis of plane we can divide the chromatography into planar chromatography and non-planar or open column chromatography. Under this planar chromatography, which is a 2D type of chromatography, we have thin layer chromatography, we have paper chromatography, we have circular paper chromatography, circular TLC chromatography, while in non-planar or open column we have all the liquid chromatographies like HPLC, high performance liquid chromatography, the basic one column chromatography CC, then we have GC, gas chromatography, we have GLC, gas liquid chromatography, etc. Okay. So, all these come under the category of column or open tube chromatography. So, here are based on the principle of separation, chromatography can be classified number 1 as adsorption chromatography, and it is the oldest type of chromatography around, where the mobile phase or mobile liquid or gaseous phase gets adsorbed onto a surface of a stationary solid phase. Believing that this is the silica or any solid phase of cellulose paper, the stationary phase SP will get adsorbed onto these phase when the sample is applied. That time this gets adsorbed, and the equilibration between the mobile and stationary phase accounts for the separation of different solvents. That means once this gets adsorbed, the mobile phase is passed through it. This mobile phase will detach the adsorbing material. Supposingly this is A, this is B, and if it solubilizes, it will be taken at the faster speed than the B component, which will solubilize in the later. So, A would be eluated fast, as it is having the affinity or likability with the mobile phase more and less likability with the adsorption or the stationary phase. So, depending on this, the separation of the solute will takes place. Next is the partition chromatography. Again, this is based on the principle of partitioning or separating or distributing a solute into 2 different layers. Okay, let's have a look. It is based on thin film formed on the surface of solid support by a liquid stationary phase, the solute equilibrates between the mobile phase and the stationary phase. Now, here what happens? That supposingly a glass slide is kept, or maybe a column is there where silica with silica with a stationary phase, any stationary phase is there, or a silica with any stationary phase, like in case of TLC it is kept here. So, once the mobile phase starts running above it, so there will be solvation, equilibration between the solvation of this mobile phase and the stationary phase, and depending on that the separation will take place. So, if mobile phase is running through this, it will partition between the two layers, okay, stationary phase and mobile phase. So, if the solute will distribute, okay, and it will go into start going into the mobile phase till an equilibrium is established between this, and this mobile phase will carry along with it, and this particular equilibration will depend upon the partition coefficient. Again, this can depend on the partition ability and solvation ability of the solute into the mobile phase. Next is the ion exchange chromatography. So, this is it is a type and a very atypical type of chromatography, where the solid support, instead of cellulose or starch or any other adsorbent like silica, Keshelgar, a resin is used. Okay. Here the stationary solid phase resin is used, and it is used to covalently attach anions or cations onto it, since the name suggests ion. So, here the exchange of solute does not take place, but there is ions that play into a major role. So, it looks like this. Supposingly a resin, so this resin is polymer like substances where an anion or cation would be attached, and once the mobile phase comes in it will take away mainly the anions and then elute the anions. Such ion exchange chromatography is called as anion exchange chromatography, and this will happen only if the covalent bond with the resin is broken and the anion is carried with the, or the cation is carried with the mobile phase. So, let us see here. The solute ions of the opposite charge in the mobile phase are attracted to the resin by electrostatic forces. Next type is molecular exclusion chromatography. Now, if we describe it like the surface of adsorbent where various molecules of various shapes are there. Okay. Now, this molecular exclusion chromatography is highly specific and selective, you may say, that it would, among the so many different types of molecules, a specific shaped molecules would get excluded on the surface of the stationary phase. Okay. So, this is also termed as gel permeation or gel filtration, and this type of chromatography lacks an attractive interaction between the stationary phase and the solute. The liquid or gaseous phase passes through a porous gel which separates the molecule according to its size. The pores here are normally small and exclude the larger solutes. Any larger solutes would be excluded out, okay, but allow smaller molecules to enter into the gel, causing them to flow through the larger volume. This causes the larger molecules to pass away first through the column at a faster rate than the smaller ones. Next is affinity chromatography. Again, this is highly and most selective type of chromatography which utilizes specific interaction between one kind of solute molecule and the second molecule that is immobilized on a stationary phase. Okay. For example, immobilization of an antibody to some specific protein. So, here only one antibody, very specific, very selective, could be separated out, and hence it is from a mixture of molecules, and hence it is a very selective type. Okay, the protein which is later extracted by changing the ionic strength or pH, they are different types of chromatographic methods like paper chromatography, thin layer chromatography, column chromatography, high performance liquid chromatography, gas chromatography, high performance thin layer chromatography or HPLC. This is termed as HPLC. Nowadays, ultra high performance UPLC and such advanced methods are available, and all these methods are used for analysis, separation and isolation of components in the natural products. Again, discussing the type of chromatography, the first and the basic one is the paper chromatography. It is highly advantageous of the paper chromatography as it is highly convenient in carrying out separation for a large amount of substances simply on sheets of the filter paper, and it serves both as the medium for separation as well as the support. The technique was extended to maximum classes, and here the spots near one end of the prepared filter paper strip is applied. Usually several sample and standard spots are placed along the edge. Then chromatogram is developed, that is a paper recording is developed by immersing the edge of the paper in the solvent that migrates through the paper as the mobile phase. Let us see, the solvent often has 2 or 3 components, one of which is usually water, and the development is normally done in a chamber. The very commonly applied solvent preferred is for paper chromatography is BAW 4:1:5 and butanol, acetic acid and water. That is what we are communicating here ki, generally and since here the stationary phase what we are using is cellulose and these cellulose acts as the stationary phase and the moisture present in the water again. So, that is the stationary phase. This is the common solvent system BAW used for paper chromatography. Next, the water forms the solvent in particular is adsorbed tightly on the paper fibers, and the sample components partition between the waters of the cellulose and the water of the BAW. They partition between the moisture present here and the solvent system or the mobile phase. After the separation, strongly colored spots are visible on the chromatogram. Colorless materials can be visualized either by heating the paper on a oven or which leaving charred black spots. Sometimes paper is sprayed with the solution of sulfuric acid for better charring or any other reagent to visualize the substance separated. There are other methods also like fluorescent materials can be used making the visualization better with the ultraviolet ray light. Reagents specific for certain components may be sprayed on the colored spots, like we spray ninhydrin ninhydrin reagent for amino acids. Similar is the example of the sugars. Then in case of alkaloids, we spray Drazenhoff reagent, etc. Okay. Radioactive spots can be located with a detector, and the chromatogram can be pressed against X-ray films for minutes or hours to expose the film. The sample spots can be tentatively identified if they have the same RF values known as the standard spots. So, here is the diagram for the paper chromatography. We can see here, this is the developmental tank, this is the stationary mobile phase or the BAW or the solvent. The paper is hung from here, the spot is applied from the leaving 2 centimeters of distance, the spot is applied. This spot should not touch the solvent bed of the in the developmental chamber, and once the mobile phase starts moving upwards, it will carry along with it the most likable ones, and then finally they will get separated out. Generally the paper in case of TLC and paper chromatography, we follow 20 into 20 for preparatory, 10 into 20 filter papers, or sometimes 5 into 10, and along this length complete 10, almost this running 8 centimeters, or when we are choosing a 20 centimeter plate, almost 16 to 18 centimeter of the solvent run. After that the chromatogram is taken and taken for visualization. The visualization can be of 2 types as already mentioned. It can be simple with light or with chemical treatment as mentioned. Okay. So, this chemical treatment is also called as derivatization. We will follow this terms in TLC or thin layer chromatography more, and the variation with light could be visible, UV short and UV long. This paper chromatography have many variants like ascending, descending type of paper chromatography. There are 2 dimensional development also, where first the solvent front is run in this, the points or the separation will be achieved in this direction, then it is inverted, and the another second type of solvent system is run through this, and here again re-separation will take place, and these are called as 2-dimensional separation. Then we also have the separation using circular paper chromatography. This is in particularly applicable for the substances where the RF value difference is very less. For example, sugars, where the minute difference of 0.01, 0.06, that kind of minute difference of the RF values will be present. Then we have these amino acids, also essential amino acids, because of small functional change there will be lesser difference, and so there this particular paper chromatography is helpful to separate in radial fashion, and again this the passage is calculated as the movement radially as the retardation factor. So, these are some of the important discussion regarding the chromatographic techniques. With this I must wind up. Thank you.